Good afternoon, good morning, good evening, wherever in the world you are. Thank you for being with us for another session of our SAFI UAE webinar series. Today we have session 5, in which we're going to be exploring the role of the oil and gas industry in the development of the sustainable aviation fuels industry. We have with us very important and speakers that represent some of the biggest oil and gas companies in the world. And so it's our pleasure and privilege to have with us Jonathan Wood from Neste, Stéphane Thion from Total, and Andrew Murphy from Shell. I'd like to, first of all, thank our sponsors, the General Civil Aviation Authority of the UAE, Etihad Airways, Emirates Airlines, the Boeing Company, the International Air Transport Association, and last but not least, our new co-sponsor, which is Masdar, the Abu Dhabi Future Energy Company. So with that, I would like to go ahead and read the biographies of our speakers. We have with us, as I mentioned, Jonathan Wood. Jonathan is Vice President for Europe and Asia Pacific for Neste's renewable aviation fuel business. He has 25 years senior level experience in the energy industry. Prior to joining Neste, Jonathan led Air BP's global growth and business development strategy. Jonathan has extensive commercial experience in building and leading customer-facing businesses, developing supply chains, new product and service value propositions, mergers and acquisitions, JVs and commercial partnerships, as well as investments in biofuels and digital ventures. Jonathan graduated in economics from London University and completed an executive MBA program at Harvard Business School. Next, we have Andrew Murphy. Andrew is General Manager, Advanced Biofuels in Shell Downstream Transformation and Sustainability, where he has global accountability for the delivery of an advanced biofuels manufacturing business. He has over 30 years commercial, project and technology implementation experience and has worked in the renewable energy field since 2001. He has held a number of senior positions in the UK and Canada in a range of commercial, mergers and acquisitions, new business development, and trading roles. Andrew has a first degree in electromechanical engineering, is a fellow of the Energy Institute, and a chartered engineer. And last but not least, we have Stéphane Thion. Stéphane is head of sustainable aviation fuels at Total since the end of 2018. He has over 20 years extensive international experience developing sustainable and innovative renewable energy and chemical solutions for both startups and multinational companies. Stéphane was Managing Director, Asia Pacific at Ingevity, a leading global manufacturer of renewable specialty chemicals and materials. He was also at Cool Planet, a startup company dedicated to establishing sustainable products for the energy, food, and water markets. Stéphane graduated in international business and holds an executive MBA from Temple University. With that, I'd like to go ahead and introduce Jonathan, who will start us off with the perspective from Neste in terms of their work in sustainable aviation fuels. So Jonathan, please go ahead and thank you very much for being with us.
Pleasure. So let me just share my screen. So hopefully that's working for you, Alejandro. Jolly good. So I'll kick off by talking a little bit about Neste, where we stand, what the status is of sustainable aviation fuel as we see it, and then also the outlook, and in particular also the importance of the sustainability credentials of SAF. But right up front, I'd like to say Neste is very clear around its purpose, and that is to create a healthier planet for our children. So that is the orientation for the entire company. We care, we cooperate, we have courage, but above all, our purpose is around developing products and services that help achieve this objective, and doing it in a way also that is also supporting this purpose. But a little bit more about the background of Neste and how we've got to this clarity of purpose and the shape of the company as we see it today. So as you can see here on the chart, Neste was originally an fossil oil-based company, downstream company, marketing and refining in Finland, founded after the Second World War. But we've gone through a massive transformation, especially over the last 15 odd years, to completely rebalance our portfolio towards renewable fuel production and marketing. We are now the #1 producer of renewable diesel and jet fuel from waste and residues in the world, and I've been ranked for many years in the top index of global sustainable companies, ranked 3rd last year. But as I say, this is not a recent phenomenon. Neste has been in the top rankings for sustainable companies globally for some 14-15 years. And whilst we have an oil products business still, that has become very much, I would say, a second arm to the company. The arm that now is driving us forward is the renewable fuels production and marketing arm. And to that end, I mean, the production that we brought to market last year resulted in approximately a reduction in carbon emissions of approximately 10 million tons, or what would be equivalent to roughly 3.5 million cars being taken off the road. We have a very strong focus on R&D to help both further develop our production technology and in particular to understand what other renewable feedstocks can be brought into the system to make fuel products. And we have a significant investment program to grow our renewable fuels production capacity from 3 to 4.5 million tons in the next 2 to 3 years. So with that, I would say that's a little bit about Neste. Putting it in the broader context of the market we're playing in, and I'm sure I know that this slide has been shown in previous webinars. So the broader objective for the aviation industry to both grow on a carbon neutral way and then reduce emissions over time needs to be delivered by a number of means, both new cleaner aircraft, but also improved operations and of course sustainable aviation fuel. But I think what's important to recognize here is what 10 years ago was a very forward-thinking position by the aviation industry. I think we all know that society's attitudes to climate change have sharpened significantly, and we now have in many countries here listed in Europe carbon neutrality objectives, which I think are an important context and really increase the urgency for aviation to move forward down this pathway as quickly as possible. And as we all know, we now have sustainable aviation fuels available that are delivering some 80% reduction in end-to-end carbon emissions compared with their fossil jet fuel equivalent. And these are made from a variety of renewable raw materials, but are effectively being converted into drop-in fuels that can be put into the existing infrastructure and brought to market. As has been explained on previous webinars, there are now a number of production pathways that have been approved, and we at Neste are a firm believer in all of these needing to be developed and progressed to be part of the solution as we go forward, depending on what the relative strengths are and availability is of the respective regions in terms of feedstocks. But as I said, sustainable aviation fuel is now available and is increasingly being brought to market. And I think this is really the priority for all of us now, to increase the availability of sustainable aviation fuel for airlines and other flying organizations to be able to use it. So in particular, there were a number of test flights 10 or more years ago, but as I'm sure many of you know, significant progress in the Nordic region with the launch of SAF at Oslo Airport, in the commercial airport, and then in other airports in the Nordic region, but now also with sales in the Netherlands, Germany, and indeed, of course, in the US. Some of you will have seen the announcements recently about increased uptake of SAF by some of the leading American airlines. California in particular has a supportive regulatory environment. And I think that's one of the key points to make here, is that the regulatory environment is key to helping both initiate the supply side with incentives and support, but also to help provide more certainty around the demand side, and provide the right kind of incentives and frameworks to encourage the use and build the scale of the SAF for sustainable aviation fuels business. So I think I'll now move on to the future. So in terms of how we at Neste see the growth of the SAF or sustainable aviation fuel business globally as well as regionally, it's firstly key that we build on what we have available with the existing sustainable aviation fuel availability and technology with the so-called HEFA, hydroprocessed esters and fatty acids technology. That's one that we now see a number of announcements being made by different players to invest and convert refineries to promote this form of production. We believe that by further extending the supply chain for these feedstocks, that this can supply up to some 10% of total global aviation jet fuel demand. But that then we need to also be in parallel working on the next technologies, and some of your previous speakers and previous webinars have talked about this, be it municipal solid waste, Fischer-Tropsch type of feedstock and production technology, be it alcohol to jet. All of these forms, we believe as Neste, have a place depending on what the relative strengths are and feedstock availability is in the different regions of the world. And then thirdly, ultimately to move or increase the production of so-called power to liquids fuels, where renewable power is low-cost renewable power is key to enabling us to unlock the ability to create liquid hydrocarbon fuels using carbon capture from the air or from off gases, and the conversion of water, the extraction of hydrogen from water. So we see a pathway, and all of these such technologies really have a role to play, and we at Neste are very much focused on firstly scaling up the HEFA-based SAF supply, but also looking at potential projects in these second and third waves as portrayed on this chart. And here a little bit more detail about actually the investment that we've got going on in Neste right now, over and above our current production of some 100,000 tons in the European region, to grow that by 2023 to some 1.5 million tons worth of SAF production capacity, based off our next BTL technology, which we've developed to take waste oils and fatty acids. but then to, as I said, look at additional investment, both in that form of technology, but also the other production technologies that I outlined earlier. One last thing I would say is that as part of this journey, it's absolutely essential that we assure the sustainability and the carbon reduction from these different production methods and stocks. And so we at Neste are very much committed to being transparent and rigorous and working with the appropriate certification bodies to ensure that the feedstock supplies, the production, and the delivery are assured and objectively assessed to ensure we are truly delivering the carbon reduction of 80% or so that I mentioned earlier. So in short, we at Neste are committed to not only delivering but growing the reduction in greenhouse gas emissions over time for our customers. We have an objective of a reduction of 20 million tons by 2030, but then in parallel to also reduce our own carbon emissions from our own production facilities and to achieve carbon neutrality by 2035. So that's in a nutshell how we at Neste see our role in promoting SAF and the carbon reduction challenges that we face. Thank you, Alejandro.
Thank you very much, Jonathan. I think Neste for sure is one of the world leaders currently in the production of SAF and in making this type of fuel available. It has been so for a number of years, and you're in a way one of the leading companies that has actually put steel on the ground and built infrastructure to really be able to refine this product and then distribute it and of course make it available for the aviation market. So thank you very much for that. We can now move ahead and ask Andrew to help us out with his presentation, and we look forward to seeing what he can bring to the table. Thank you, Andrew.
Hi, thank you everybody. Welcome. Let me just share my screen. Can I just check? Can you see my screen? Are you seeing the presentation? Yeah, okay, great. Oh, well, thank you everybody, and thank you for the opportunity to speak to you today. I'm Andrew Murphy, and I'm from Shell's Advanced Biofuels business within our downstream organization. And we sit within our downstream organization because part of our purpose is to supply more and cleaner energy to our customers. And we recognize that we very much want to be part of an energy transition. That energy transition is progressing at different pace in different regions. And one of the beauties of my current role is that, as you saw from Jonathan's slides earlier, you get to see the global footprint and the global progression across Europe, across the US, and into the Middle East and Asia. So this really is an exciting area. Let me talk a little bit more about the role that Shell Aviation and then Advanced Biofuels has within that area. So I think, where can let's take a look at the fuels industry. One of the questions was, why should the fuels industry invest in this space? And I think it's worth noting that we're already heavily invested in the aviation space. So the future of that liquids market is very important to us. It's clear there needs to be an energy transition and a decarbonisation of all sectors. Aviation is a hard to decarbonize sector, therefore it's of interest to us as a challenge and an opportunity. And within that space, all of these aspects have to come together in order to enable a solution. And that's largely a solution for aircraft that are flying today. Because those aircraft are likely to still be flying substantially in 2050, so they have to be part of the solution. And bringing all of these aspects together from supply chain and logistics through production, investing, off-taking, product quality and assurance, trusted partner for putting fuels into the wing. These are all important aspects of delivering an integrated downstream solution for aviation. And I think, you know, it's often important to remember that bringing all of these different aspects together is important in terms of delivering an end-to-end solution. The fuel has to be produced and it has to get into the wing. So having looked at those, let me now look at fuel producer and investor in a little bit more detail as we go into this presentation. The space is complex. There are, as Jonathan mentioned, 7 pathways currently under approval, and there will undoubtedly be more. Some will succeed, some will fail. And I think from an oil and gas industry perspective, you know, part of the reason for this slide is to, you know, unlike oil and gas, you really do have choices in terms of your feedstocks, in terms of your core carbon sources. So what you would like sustainable aviation fuel made from is extremely important in terms of finding the solution that's appropriate and finding the price point that's appropriate that we'll come to in a moment. As we look at this chart, as we have carbon sources, feedstocks on the left-hand side, from carbon capture down through cellulosic materials to today's wastes and residues. These are all potential feedstocks, which together through a variety of processes for wherever you see the shell pectin here, you know, we believe we have competencies that we can bring to these areas, either through our own competencies from the technology centers that we have, or from our partners' perspective, where we're already invested in Raízen sugarcane ethanol business in Brazil, which produces 2 billion liters of low carbon ethanol today. So these are all potential sources of feedstock for the aviation industry, and through a number of technologies, and again, I agree, all of which will be relevant to producing fuels moving forward. We have capabilities from hydrotreating to bring to HVO. We have a Brazilian business for feeding an alcohol to jet capability. I'll touch in a moment on our IH² technology, which is a particular technology we're developing in India. And you know, for many years, we've been a leader in the Fischer-Tropsch and Synfuels space. So these, not only in terms of supplying our customers with low carbon fuels, are important drivers in their own right, but from a capabilities perspective, from an experience perspective, you know, we really do feel as though as Shell, we have something to bring to the table and capabilities to bring to the table, which are true for us and are true for other players in the oil and gas industry where they have relevant expertise. So I think this is the simple message is for the oil and gas industry that this is a space in terms of technology that we know well and we understand fuels extremely well, and therefore we feel it's the right space for us to be operating, for us to be investing in, and for us to be part of the solution moving forward. And we have particular capabilities in Fischer-Tropsch, Synfuels, and hydrotreating, and particularly in IH². So let me move on to just touch on IH² for a moment. IH² is our own technology. It's a gasification pyrolysis-based approach to converting many forms of waste and agricultural residue type biomass into a drop-in substitute fuel. So this relatively simple technology converts those biomass without external hydrogen, which is very helpful in terms of the ability to deploy this technology, you know, widely. And it produces drop-in fuels which are on spec and are going through the approvals process in the US currently. We're currently in the de-risking phase. The bottom right-hand corner was the latter stages in 2017 of the construction of our demonstration plant. That continues to be operational in Bangalore. with a slight break for COVID in the earlier part of this year. And it's a technology that we're very excited about. We hope to be bringing it to market when we go through our final testing in the near future, and we can see that that has an application for sustainable aviation fuels, as well as other road transport fuels as well. So our experience in catalyst development through Shell Catalysts and technology is extremely helpful here in terms of providing the right conversion technology and the right catalyst to produce the right fuels mix going forward. So again, as Shell, this is an area where we feel we bring multiple capabilities to the table to allow us to be part of these solutions going forward. But it's not just about technology solutions. It very much is around finding the right combinations of feedstocks and regulatory or customer demand for the product. Those are two important, extremely important aspects of the advanced biofuel sustainable aviation fuels proposition and offering to customers. So many people ask me about technology for advanced biofuels and advanced biofuels conversions. I always change the subject back to asking about combinations of feedstocks and products products which are either have customer or regulatory demand. It's those two things you have to get right. Technology happens to be the enabler. Extremely important. Without it, you can't make the product, but it's the feedstock and the demand that work together. So when we look at that, yeah, undoubtedly today HEFA or HVO is the most commercially viable option. But as we look at this more closely and start to examine some of the commercial price points, this is all commercial data, external data. It's not Shell data. It is illustrative, but it gives you the sense of the relative cost combination of feedstocks and the product, which is all sustainable aviation fuels today. So what you can see is on the left-hand side, from a variety of sources, HVO stroke HEFA is in the, broadly speaking, $1,000 to $1,500 per ton range, and this is based on a simple levelized cost of production basis. So simple return on capital plus OPEX. And people have different views on the sustainability of those feedstocks. They have different views on the affordability of those prices. But that's the combination that you see from HVO HEFA. And unsurprisingly, as you look at other combinations, they get more expensive. And that's the combination of either scale goes smaller, or that the complexity of the feedstock conversion is more, has more steps. And therefore, as you're thinking about alcohol to jet, which is the next 4 blocks on here, and then you're thinking about Fischer-Tropsch after that, what really matters is what's your source of carbon, how much conversion capital does that take, and what's the outcome price point derived from that combination. And these may not be entirely correct. I'm sure there'll be lots of views from many people on the relative price points here. But I think ignoring the actual price points, but the relative price points are reasonably robust. So it's very important for us as fuel producers and for investors, as fuel producers and as investors, to understand how the combination of feedstock technology manifests itself in product prices going forward that are affordable and robust on a long-term basis. And I think finding those combinations and working together to underpin these investments with demand is going to be an extremely important collaboration for the industry moving forward in order to enable this transition to go to move at the pace that everybody would like it to move. So I think it's important to remember feedstocks and regulatory couplings with demand, and also the relative price points that those give you, because they lead to affordability, and they lead to investability as well. And those two things are very important for the sector. Which takes me to the final point. This is a world in which, you know, we all have to work together in order to deliver either technology solutions or industry solutions that enable the industry to get going. There are many examples of how industry and customers or regulators have come together and promoted and created demand for products. There are good examples, there are bad examples. You know, what's important is that actually that we start to see capacity coming forward, and we find the right conditions for those investments to be made. Those can be made by oil and gas companies on our own. We need to see that line of sight through to return for our shareholders. We believe it's the right thing, the right theme for investment moving forward. But working together, I think we can create much stronger coalitions and much stronger partnerships that will allow the industry to move forward at pace. So let me finish by saying thank you, but you know, please remember our view as ever is that working together we go farther. Might not go faster, but we'll go much farther. Thank you.
Thank you very much, Andrew. I think you've laid out a very clear view from Shell's perspective. The slide where you showed all of the different pathways was very helpful to our discussion, because it clarifies many of the things that in many circles are not well understood. And so we will hopefully be able to get into a discussion around this. But first, let us ask Stefan to go ahead and do his presentation so that we have some time at the end to enter a fruitful discussion. So Stefan, thank you very much.
Can you hear me well? Okay, well, first of all, I'd like to thank the SAFI UAE for the opportunity to talk about sustainable aviation fuel. My name is Stefan Thion. I work for Total, and I'm responsible. I'm heading the Sustainable Aviation Fuel Initiative for the group. I belong to the refining and chemical branch, and I have a very strong and tight relationship with my colleagues on the marketing and service, namely Air Total International, who happens to be the commercial face of Total vis-a-vis the airlines and the airport. And we work collaboratively together and trying to develop sustainable aviation fuel within Total organization and in France, in Europe, and around the world. I have the hard task to go behind Neste and Shell. There are going to be some repetitive information. I'm going to try to go fast on the one that have already been highlighted and try to add something a bit different. The first slide was already presented earlier by Jonathan. What we've tried to do on this one, though, was trying to put things in perspective and look at where the aviation sector is actually, if you count about 300 million tons of jet being sold globally, it would be a billion tons of CO2 emission. And the impact of the COVID on the reduction of the emission of the aviation, if you consider the traffic drop between 30 and 40%, and those numbers can be revised along the way, we would be at the end of the year around 600, 700 million tons of emission of CO2. And if you remember correctly, the CORSIA system of compensation was supposed to take the average of the emission between 2019 and 2020. Given what happened in 2020, it was decided that 2019 will be the point of reference. Given that the industry is projected to get back to normal in the 23-24 timeframe, it means that until then, it's going to be difficult for the industry to go beyond the emission of 2019. And it's being provocative comment, but one can wonder what would be that impact on the development of the SAF. And I'll try also to provide a bit of answer along the presentation. So we have a tight objective of reducing emission by 50% in 2050. And the new additional technologies, the new biofuel is a big lever for this. When we talk about sustainable aviation fuel, and some people have different definitions, so we tried here to highlight and simplify things. And basically we have two different families: the conventional fuel, the fossil-based, whether it's Jet A1 or the avgas, and then the alternative. And within the alternative aviation fuel, which by nature will reduce the greenhouse gas emission, or the CO2, we have three different categories. We have the sustainable aviation fuel, the natural gas, and the hydrogen. The SAF has the particularity and the advantage of being able to utilize existing engine and infrastructure, which is kind of what the industry is trying to do. And that's one of the reasons Total is actively involved in developing sustainable aviation fuel. You'll see I have a slide that is very similar to the one that Andrew presented, where you see all the different pathways and how do you associate a particular feedstock to a technology. That's what's fascinating about sustainable aviation fuel. You have optionality of what kind of feedstock can be used and applying a different technology to get the sustainable aviation fuel molecule. We look at it between the biofuel, recycled carbon fuels, which today is still a bit of not a no-man's land, but it's difficult to find a house as far as the regulatory perspective. And then the e-fuel that a lot of people have hopes in. And then we have the natural gas and the hydrogen that Total is involved as well and trying to collaborate with industry players. But we see that as more of a long-term solution, understanding that today out of the 20,000 plus airplanes, about one might be retired because of obsolescence and replaced, but the two-third will continue having a span life of 20 years. So the liquid fuel will be there for a long time, and that's where today Total is putting a lot of the efforts, along with natural gas and hydrogen, more of the long term. When we look at the different pathways, and I think Andrew mentioned earlier, today there is about 7 pathways that have been approved, STM approved for sustainable aviation fuel. There is more than a dozen in the pipeline in the tier 1, tier 2 category. The interesting thing is all those different pathways, Total is actively looking into them, either by already producing, like the HEFA technology. We've done a retrofit of the La Med refinery that has the capability of doing both the HVO, the biodiesel, and the HEFA. We've been sponsored of a synthesized isoparaffin with Amaris, which is one of the direct route from edible sugars in the category of alcohol to jet, along with the LenzaTech and the Gevo. The Fischer-Tropsch, looking at wood residue, municipal solid waste, into where we categorize the biogenic piece versus the recycled carbon. And then the power to liquid, where we see tremendous potential if access to a very low energy cost when you do either recuperation of CO from steel mill or other industries, or CO2 capture, CCUS, or direct air capture. And then the last but not least, where we see great opportunity to actually bring kind of a economical molecule, the fastest way on the market is co-processing. It means for an oil industry, using an existing refinery and so existing assets requiring very minimal capex, and being able to incorporate a fatty acid, a vegetable oil, or a bio oil that is an intermediary product from a process such as the pyrolysis or a Fischer-Tropsch, and having that tool to be able for an oil industry to rapidly put biomolecules on the market if the market needs it and if the proper regulatory is in place as well. So Total sees that as a great opportunity as well to bring SAF on the market. We looked at those levelized cost of production and a bit of a mix between what Jonathan has presented into looking at the waves of how the SAF, we envision the SAF to develop over time, and Andrew, where it's like this one is more of a summary. And I tried to put that in perspective with a Jet A1 in a standard world where the barrel of oil is about $60. We see that HEFA happens to be the most economical way of producing sustainable aviation fuel, and today it is the commercial technology, the people that are deploying new capacity. And then we see alcohol to jet being another good opportunity to deploy sustainable aviation fuel, especially with some technology that would convert directly ethanol to jet, given the existing ethanol capacity. And we foresee that in the automotive industry, with more share for the electric cars, it will probably free up some capacity that down the road can be utilized. We see Fischer-Tropsch as well as a great way to achieve some of the objective of the aviation sector, given the variety and the size of the municipal solid waste around the world. And then down the road, we see power to liquid and the e-fuels being also a great way to achieve the decarbonation of the sector. But for that, we'll have to have a reduction both in capex and access to electricity. So that's kind of how we see the market progressing into those three waves, such as what Jonathan has described. And on the top, you see what are the drivers of those technology. In the HEFA technology, access to feedstock is key. It accounts for about 80% of an LCOP. So as soon as you gotta lock your feedstock at a low price, it will make a SAF more competitive. On the alcohol to jet, it's feedstock as well. Fischer-Tropsch is a bit more capex incentive. And then for PTL is more of a mix between a capex and access to low electricity. But no matter what, and that's what the industry and the aviation sector has a hard time maybe to digest, is those technology in a world where a barrel of oil at 60, even if it was at 100, a sustainable aviation fuel will be more expensive unless the market dictates a carbon tax or a carbon in the $300 or $350 per ton. It will always be more expensive, and we assess that it's between 3 and 6 times more than a Jet A1 at a $60 a barrel, more or less. And we've done a little analysis of the capacity to come, and we'll try to compare that to what the market sees by 2050. We see more and more airline taking the initiative to announce a net zero by 2050, and of course incorporation of sustainable aviation fuel is a way to get to that point. We see some countries and national initiatives, and I'll talk a bit more about French initiative later, that are starting to talk about mandates. One in Norway has been started this year. We might see some in Sweden starting next year. France has been talking about one. UK has an objective of reduction of CO2 emission. Spain has been talking about a roadmap. So is California, so on and so forth. But when you look at the different projects that have been announced, and those have been pretty much press release, and those are pure announcement, you see that we're expecting about 1.8 million tons of HEFA by 2025. There are a few projects that have been announced and some ambitions from LanzaTech and JEVO for the alcohol to jet. Fischer-Tropsch, 3 companies are taking the leads, and they've announced project. And then the latest SAF approved pathway, CHG, that has the opportunity to do both the HVO and the HEFA as well, could be another potential. So when you put all these potential together by 2025, you're talking about a capacity of close to 2.5 million tons in a market under normal condition that is between 300 and 320 million tons. So that's still very, very small share. And here, just to put things a bit more in perspective, you have the breakdown of those technology and also by geography, where you see it's pretty much balanced. It's very well balanced. When you project what could be SAF in the future, for some local initiatives, some announcement from the IAA, the ATAG that has a scenario based on the 50% reduction of the aviation sector, the first slide I showed, Safran or Rolls-Royce, the motorist, they all have a different vision, but one can say that besides the IAA, that maybe it would be somewhere in the range of 200 and 250 million tons by 2050 from a 2.5 million tons projected capacity announced in 2025. So that's a big jump, and it will require, and that's why I guess, you know, we all insist that it's not going to be just one technology that will satisfy the needs of the market, but collectively all those different technology associated with the different feedstocks. And I'll come to the Total that has recently announced a ambition to get to a net zero emission by 2050. And we'll do that with different strategic focus and levers to get that. And one of the lever is obviously to, and especially for Europe, because we say we'll be net zero in scope 1, scope 2, scope 3. So not only our operation, direct and indirectly, as well as the products we'll put on the market, the integration of biofuels is part of our strategy, and incorporating more and more biofuel, as well as carbon sink is one of the levers of getting to and to that objective and that strategy. But Total has not been waiting for this new climate strategy to come along. We've started initiative into sustainable aviation fuel over a decade ago, and we've been, like I said earlier, one of the sponsor to obtain the ASTM SIP pathway approved back in 2014. We've done many commercial flights with the Air France, with the national, international flights, work tightly with Airbus and incorporate some sustainable aviation fuel in some of their plane delivery to airlines. We've managed to do a co-processing industrial trial and test successfully last year in May of 2019 in our Normandy refinery. And we have big hopes that it will be one of the ways to get sustainable aviation fuel in the Paris airport in the near future. And then and our friend from Air Total International have made a deal with JEVO for a commercial agreement for 3 years, as well as the capability of our refinery La Med, if the market is there, if the incentives are there to get to sustainable aviation fuel. So the way we look at the role of an oil and gas player in the aviation sector is 3 ways. And we believe we need those 3 together to be able to get sustainable aviation fuel taking off without play on word, but got to support expansion capacities. And the way we look at it is we have many refineries that down the road, especially given our new ambition, most likely will be retrofitted into a biofuel refinery. So existing capabilities transform into biorefineries, as well as looking into seeking partnerships. And I think that's key. That's Andrew that said that. I think Jonathan as well said that. Everybody will agree that you cannot be successful if you do that alone. You're gonna have to be and partner with people, whether they're raw material suppliers, technology partners, airports, supply chain. It's a whole that will make, you know, these crusade successful. We got to expand, which comes to the next step, is expanding collaboration with OEM, with motorists. I mean, at Total, we see ourselves as a energy integrator. So we have to work with the motorist and the OEM, as well as every logistic piece in place and the airports together. And then the big part of it as well is advocacy. And because we've seen initiatives and sustainable aviation fuel to be, has been around for a long time, but yeah, we haven't seen anything really taking off. It's very small volumes. Announcements have been made, but to date, it's still not happening. So we do a lot of advocacy. We're part of the IATA, the ICAO, ATAG. We belong to European Association that has ear with the Commission, whether it's Arts Fuel, the Fuels Europe as a refiner in Europe. Flight path has been somehow a bit maybe more discreet in the latest year. European program like Bio4A to bring sustainable aviation fuel on the market. ERAG initiative in Germany, belonging to RSB, who's been promoting sustainable aviation fuel for a long time. Andrew mentioned the World Economic Forum and the initiative to the Clean Skies for Tomorrow, CAFE initiative, and this initiative in the Emirates. So what we try to do is to be as active as possible in promoting sustainable aviation fuel. Because the ECV, the Engagement pour la Croissance Verte, is a French initiative, and it's been a success from our point of view. Anyway, the first few chapters that has been written, and we hope it's going to lead somewhere. I wanted to spend just a few minutes talking about the French Green Deal, or the ECV. It was started in 2018, and it ended in mid-2019. It's a consortium partners between a government organization, environment and climate, as well as the aviation, and a few five private partners that are Suez, Safran, Airbus, Air France, and ourselves, Total. And the objectives was to come up with what does France need to do to get proper conditions to get the emergence of the sustainable aviation fuel in France, and deploying production facility, having the right infrastructure and economic mechanism to favor the deployment of projects in France. And we've identified a few levers that were published, and we had a special event in January of last year on the Airbus site in Toulouse. We announced the conclusion of the work, the ECV. From there, our Minister of Climate and Environment announced the French roadmap to be 2% incorporation of SAF by 2025, 5% by 2030, with the objectives of 50 by 2050. And then in the meantime, there was a launch of Call for Expression, or Call for Project, AMI, Appel à Manifestation d'Intérêt, that were closed at the end of July. And we're hoping that those projects will be looked upon, and hopefully France will, in the next national law, come up with a mechanism that will enable projects to flourish in France. And Total has been very active in the Green Deal from the beginning, and active in depositing projects as well. And we hope it's gonna lead to something great, and we're gonna start seeing French kind of an example for the rest of the European country, and see that spreading across Europe, hopefully. Last but not least, I wanted to conclude, and I call that the ASAP effect, which is to get SAF as soon as possible. We need availability of SAF. It's good to see that we have upcoming capacity up to 2.5 million tons to this day, with a lot of offtake forward, and I hope those offtake will secure some startups that are starting to finance the project, and to see some capacity being built up. The sustainability aspect of the projects and SAF has been touched upon a little bit earlier, and it's going to be something critical for the industry. The use of waste and residues versus food versus fuel, and I think there's a big pressure from the society to go all the way to as sustainable as possible, and use mostly waste. We see a big premium for the sustainable aviation fuel, a multiplier of up to at least three to four, and that is a big challenge for the airline industry, especially given what they're living today and post-COVID crisis, which leads to, last but not least, policy. And I think that's why we put emphasis on the advocacy as well. Is we need stable long-term policy to be able to have visibility and start getting some staff demand for real. And that concludes my presentation. So thank you for your attention.
Thank you very much, Stefan. I think that it's very interesting what's happening in France. It's very interesting all of the efforts that you have put together, that Total has put together. And it's certainly an interesting time. We have pushed ourselves right against the hour mark. And so yes. I would, if our speakers are okay with it, we can stay a tad longer, 5-10 minutes, just to try to answer a couple of questions. And there's one in the question and answer box that I think is interesting, and it says, within the CORSIA context, reduction of CO2 emissions via use of conventional aviation fuel plus offset credits is a viable path compared to using sustainable aviation fuel plus conventional aviation fuel blends. And so the question is, where do the panelists see the price point for CORSIA eligible carbon credits settling at in terms of US dollars per ton of CO2 equivalent when you plan your SAF production strategies? That is there a price of carbon? And if so, I mean, some of you have mentioned that, right? And I think the price that you mentioned, Stefan, was around $300, $350. And then how does the sustainable aviation fuel development strategy in your companies integrate with other activities such as carbon capture, use and storage, or other key technologies that are again have to be part of the supply chain of sustainable aviation fuel? And so if anyone can comment, perhaps we can go back along the same order. If you can comment, Jonathan, and then Andrew, and Stefan, please.
Yes, so I mean, we see sustainable aviation fuel as being needed as part of the long-term solution. Regardless, carbon offsets are a mechanism out there, but I think aviation needs to, as an industry, reduce its net end-to-end carbon emissions within its own scope of activity, rather than effectively embarking upon offset projects in other sectors. So that's our philosophy. Yes, carbon offsets certainly have a role to play, but we believe that the sustainable aviation fuels with a much lower end-to-end carbon emissions is the area that we want to focus on.
Thank you, Jonathan. Andrew, I think that Shell has significant has looked at other, at specifically the option of reducing carbon emissions via offsets, and they have a portfolio of projects around the world. So perhaps you have a slightly different take on this.
I think carbon offsets, nature-based solutions are an important part of the solution set. So we are actively developing a number of these opportunities because we believe they're going to be part of the solution going forward. How they're used within each sector is really up to the combination of sectoral regulations and customer demand. So we see them as part of the solution, but I think the important thing to remember here is that where there are solutions like sustainable aviation fuels, those are likely to be required to be used because the number of harder to decarbonize sectors that don't have solutions are where the offsets will probably end up being applied in the longer term. So all of these are required. Good, solid, sustainable solutions are required in all sectors, but I think where aviation has answers, then there'll be pressure for aviation to use those fuels. And I think you've seen the charts. There will undoubtedly be cost savings going forward where capital intensive projects get cheaper over time. And what you see currently are prices for project costs for early projects rather than the end game. So inevitably things will get more competitive over time. But what's really important are cheap sources of green or biocarbon and cheap sources of green or of green hydrogen. And where those two to come together, you'll see sweet spots in terms of production and much lower costs, and you'll see where they don't come together. So we're very much looking on a global basis to find the right combination of low cost inputs.
Thank you, Andrew. Stefan?
Yeah, we are too, and we look at we have a nature-based solution, looking at the business for our activity as well as a service that we provide to some of our customers, and so that is one thing. But offset is just offset. It's not going to be decarbonizing anything. So in Total, we work very tightly with the other branches. We have a dedicated CCUS business unit with whom we work. We're looking at projects where we could be using some carbon and electrolyze and looking at e-fuel in Northern Europe. We are working tightly also with, and that's how the SAF strategy integrates within the group, but with our venture capital group that has access to startup companies and seeking to develop new types of businesses, new technology. So we go ahead and fund companies that have developed interesting technology that could be used for the SAF or for the aviation sector, for the road as well as the marine, because there's some similarity between all those sectors. And then we have a cross R&D group that looks at all the different, that has a view on all the different branches and some of the initiatives in the branch, and look at overlaps to see how we can integrate better through the organization. So that's how Total is working together and partnering with the other branches and business units.
Thank you, Stefan. I think that, to me, it's very interesting, some of the points that were raised during the presentations. One of them specifically that was raised by Andrew that said, in order for us to have SAF or to have any other product per se, we actually need to have both the feedstock and the demand, right? And in most of your presentations, you talked about the availability of feedstock as a key point, but I would like to sort of bring the discussion towards the center of our universe, which is the UAE and this region of the world. As you know, this region of the world has essentially, no fresh water, no large-scale agriculture, no biomass per se. And so, our capacity to produce sustainable aviation fuel from the traditional feedstocks that have been considered or are being considered in Europe, in the US, and in other places in the world is simply not available. However, on the other hand, we do have certain advantages, and some of them you also mentioned in terms of the capacity here for producing low cost, low carbon energy. You know, the UAE has one of the largest or some of the largest solar PV parks in the world that have achieved, you know, world record prices in terms of, you know, US cents per kilowatt hour. And in most of the models that I have seen, at least, and perhaps you have other information that you can share with us, the key or the, you know, driving factor for the production of these electrofuels or power to liquids is the cost of energy. Of course, capex is a key point here. But so, and you've mentioned in each of your presentations that you see this, of course, as part of the portfolio of solutions. But what is your take for a place like the UAE, for a place where there is no biomass, where there is no chance for us to produce HEFA type fuels, and where there is a significant demand, right? The UAE is ranked 3rd worldwide in terms of revenue ton kilometers and revenue passenger kilometers, only behind the US and China. And so that is, you know, we have the demand, but we don't have the feedstock per se, at least in the technologies that are being put forward right now. And of course, down the road, do you see, you know, certain opportunities to leapfrog and perhaps move ahead in the power to liquids space, you know, from an overall perspective from each of your companies? And perhaps we can start with Stefan this time and then move back.
So to get back to the economics of a power to liquid, you're right. So the capex and the electricity are the two most impactful of the levelized cost of production. But the capex is still the most. Between 50 and 60% is the capex, and the electricity can play between 20 and 30%. So they're both very important. And today we've seen the sector that has done dramatic reduction in capex. So that is optimistic for the future to see more reduction in capex and get a more accessible, you know, lower LCOP. Some players believe that, and France has a portfolio of nuclear plants, you know, that gives us access to a cheaper electricity compared to some other countries in Europe. And one can argue that, you know, nuclear is kind of a clean energy because there's almost no emission. So one option could be, in the UAE, is starting some projects to convert part of that nuclear electricity into liquid fuel. That could be one option. In the UAE, there are some companies in a smaller scale that have applied a 100% circular business model where they recycle some oil from restaurant and take that and convert it into a biodiesel. You could think about setting up something that would give the opportunity to collect those vegetable oil in the region, not only the UAE, but in the region, in a larger scale, to get to a substantial amount that you could convert into sustainable aviation fuel as well. And then some R&D effort and projects, I think, are important. And one example is, and you're aware of this one because you led it, the Salicona project is a good example of what could be used. But as you said, I mean, you have water, you have lots of land with sun, so sun and photovoltaic could be also an option. I think there's a lot of opportunities to deploy projects in the UAE, given also the right incentive to get things started as well. So, and raising interest.
Thank you, Stefan. Jonathan?
Yeah, well, I think we've touched upon all the options. I think power to liquids must be an option given the renewable power, cheap renewable power potential you've got. Municipal solid waste could be a shorter term option, but I think it's key that the policy is there to help incentivize it, also from a demand point of view. So setting a stake in the ground and saying at a certain point in time we want to be taking a certain proportion of aviation fuel as SAF, and mandating it or putting in place the right kind of financial incentives will then drive the choices. It's too, I mean, I think some of the other speakers have said previously as well, you know, it's very difficult to pick the winners, but if you put the right incentives in place, the winners will come to the surface. And then I would say in the short term, if the UAE wants to, as a major aviation market, demonstrate its commitment, then the current technology, HEFA-based SAF is available. But once again, it needs the right kind of incentives, but that can be the start of a trajectory and a journey.
And Andrew, I mean, obviously Shell has participated in other alternative fuel projects here in the region, you know, gas to liquids, and other, you know, important technologies that could be applied here. What is your take on this?
I think, yeah, just to say something a little bit different, I think the other thing to think about is scale here as well. So eventually, if you look at the scale of production today for aviation fuels, you know, and challenge yourself to think how you can get to that scale going forward, then the combination of CO2 and power to liquids is an obvious area where you can see synfuels and Fischer-Tropsch coming together. So I think the benefit you get from taking the low cost inputs that you have and then combining that with scale, it is potentially a means of pitching a different point on the cost curve going forward and being competitive earlier. So it is interesting to think through how that can happen. But I think what enables it is scale and aggregated demand, because you need the two of those to get to the right point on the cost curve. But it's both of those are interesting to us and challenging to us as well. So I think, you know, we're thinking about industrial syngas as well, waste syngas as an intermediate source, because that's just a different, you know, another point on the cost curve for carbon that might be an intermediate step as well.
I completely agree, and thank you for that. I guess you know, we could stay here talking about this for many minutes. You know, I don't want to take more of your time. I thank you very much. I would like to just you know, close out with a closing thought in terms of the future of SAF from each of your perspectives. You know, we have that long-term goal, reducing aviation's net CO2 emissions by half of what they were in year 2005 by year 2050. It is a goal that is being revised and discussed as we speak. There's a long-term aviation goal group that has been formed, and they're actually meeting right now. And so, you know, what is your take on the future of SAF, and where is it going to, where will it be? You know, just you know, and perhaps we can start with Jonathan and then finish off. Well,
it's got to be part of the future. It's not the only component of the future, but it's got to be part of the sustainable aviation industry, and we've got to start getting some momentum. So setting some targets will really help drive the action to achieve those targets and move to the next step beyond through policy to help set the right framework for investment. So I'm very excited about the future, and as some of the previous speakers have said, you know, aviation does need liquid fuels. This is not one that you can electrify in the same way as other fields. So so I think this is going to be our focus.
Thank you, Jonathan. Andrew?
No, I agree. There's a strong need for liquids going forward. This is an area where we have some solutions, and I think what's important for moving forward is voluntary demand as well as regulatory demand. The more we see a business starting to form that isn't reliant on regulations which are constantly debated and renewed every 5 or 10 years, then that voluntary demand will become very helpful in terms of giving everybody confidence to move forward. But I strongly believe in sustainable aviation fuels as being required, but never confident enough to believe that's the only solution.
And there's a comment on the question box that sort of tries to address that, because it is asking, what is your opinion on the on the willingness of passengers to pay for this, right? If you were going to be charged a $5, $10, 10 euro surcharge on your ticket to pay for the sustainable aviation fuel that you're using, maybe there's a change of that, right? And we didn't address that here because we will be addressing that in later sessions. But sorry, Stefan, your closing thoughts.
No, I just would add to what Jonathan and Andrew said. It will be a multiple solution down the road, but at least in the short and medium term, I think SAF is going to be the way for airline, kind of a license to operate. They will have to go through the SAF to be able to stay within the game and continue their operations, because the other ways, efficiency of airplanes will be always their first choice, because that's their core business. Offsetting can go so far. So SAF will play a central place in their strategy. And to me, that's their license to operate and to continue conducting their business. And
thank you very much.
So.
No, thank you very much. Thank you, Jonathan. Thank you, Andrew. Thank you, Stefan. Very interesting discussion. As I said, I wish we only had more time to continue this, but I thank you very much for your inputs and for your time. And we will see you next week in our 6th session of the SAFI webinar series. Thank you to all the attendees, and thank you to all of our panelists. And with that, I'd like to close the session and thank you all.
Thank you very much.
Pleasure. Bye-bye.